We are going to solve this double integral that we see here. So let's start off by noticing the inside of our integral has a dy there. And we're actually going to highlight the inside, the complete inside here. We're going to think of this as having a huge parentheses around it. And we're going to do this chunk, and then we'll look at the outer bit of our integral. So for now, we're just going to copy paste the 0 to 3. Notice we have a dy here, which means we are integrating with respect to y, and we're going to treat x like we would just a constant or any old number. So the antiderivative for x in this case, since we're thinking of it as a number, is going to be xy. Plus, in our antiderivative for 2y, we have 2y. We are going to add 1 to our exponent, divide by our new exponent. And we are evaluating this from 1 to 2. And don't forget, we're going to tack that dx on the back side again for our integral. So I'm just going to put these parentheses around here that we're still working through here. As we move forward, we're going to have, again, a 0 to 3 is still going to be there. We have one of the things to notice, we'll simplify this a little bit. This is xy plus y squared. Our 2's are going to cancel. We are evaluating from 1 to 2 dx, and I'm going to put parentheses again. So now notice we are only putting those numbers in for the value y. So this 2 and 1, we are only going to be putting in where we see a y. We're going to leave our x alone by itself. So we end up with 2x plus 2 squared minus 1x, so I'm just going to write that as 1, plus 1 squared dx. We're going to simplify this a little bit further. So this is going to give us from 0 to 3, 2x plus 4. And if we distribute that negative sign, we're going to get a minus x minus 1, minus 1 dx. And let's simplify that even further. This is 0 to 3. We have a 2x, a minus x, so this is going to give us a single x. And then we also have a 4 plus 4 and a minus 1. So that is going to give us plus 3 dx. Now this equation right here, as we look at it, is so much easier to solve. We know how to integrate x plus 3 over x. So let's do that. The antiderivative for x is going to be x. We are going to add 1 to our power, divide by 2. The antiderivative of 3 is 3x. And our bounds here are 0 and 3. So we're going to punch that in. That's going to give us 3 squared over 2 plus 3 times 3 minus 0 squared over 2 plus 3 times 0. So this second part here is going to cancel out. All of that is going to turn into a 0. And that gives us 9 over 2 plus 9. And I know all the folks out there would love it if we actually put that together as one number. 9 can be rewritten as 18 over 2 because we want a common denominator. And when we have the same denominator, we can add everything on the top together. So that gives us 27 halves. And there is a solution to our double integral, which is a lovely thing to look at. Thank you for listening.